Good afternoon. I'm Eric Krzeslo from SoftKinetic, and I'm going to talk about how 3D depth sensing technology can be used for VR, and more specifically for multi-user experiences. And that works as well. So first, what is depth sensing technology? At SoftKinetic, we are building a stack of technologies from a special sensor, which is called a time-of-flight sensor. I won't enter into too much technical details, but it's a very special sensor that senses distance for each pixels instead of sensing colors. That's really the core of the technology. On top of that, we are developing camera modules that uses, of course, our sensor, and then a bunch of software libraries specifically for human tracking. So for those who are not familiar with the depth sensing, I've got a small video showing what it looks like. So on the tablet, you can see the raw data capture from the sensor. So you see it's really in 3D, it's a point cloud that the sensor is capturing. Those are really the raw informations. And then on top of that, you can start developing your software algorithms to extract information that may be useful for different use cases. And so talking about use cases, with that technology, you can really address a lot of different platforms and use cases. So in terms of use cases, we are categorizing that in 3 families. The one that we call active control, the one at the bottom. It's basically everything you can do to detect what a user is doing, and a user that wants to actively control a device or system. So it's basically gesture recognition. You also have what we call context awareness, and that's the opposite. That's when a device using a depth sensing technology is monitoring what's happening in the scene, in the room, or in the car, whatever. And then the third category that we call real-world acquisition is basically everything related to 3D scanning, so really data capture from the scene, reconstructing objects, rooms, persons, etc., etc. So, and you can really use that technology in a lot of different platforms, in cars, in TVs, in robots, in drones, in computers. And of course also on VR and AR HMDs. And that's what we are going to talk about today. But before that, just wanted to show you a couple of examples of where our technology has been used so far, but I see that the video is not really working. Maybe it's working there, but it's not really working there. That's too bad. So, okay. So basically what you are supposed to see here is the new BMW 7 Series using our technology. So our camera has been embedded in that car, as well as our gesture or hand tracking software library to basically control your infotainment system with a simple gesture in the car. So you can control your phone calls, you can control your GPS, you can control your music with simple gestures. Of course, it has a kind of a gadget side of things, but it's very efficient in terms of reducing the driver distraction, because you can keep your eyes on the road. You don't have to touch buttons or look at a touch screen in the central console. And that's really only the beginning in cars. We are rolling out in other cars, but also for new use cases such as driver monitoring. So really looking at if the driver is distracted, is he falling asleep, etc., etc. Another product closer to the conference today where our technology is being used is in the PlayStation 4. And here it's only about software. So our full body tracking software is available on the PlayStation 4 using PlayStation camera, which is a simple stereo camera. So that's not our sensor. Essentially used in party games so far. So next here, yeah. So let's talk about what we can bring with our technology in the augmented reality and virtual reality experience. So we can improve or even create use cases that are really interesting in VR and AR. So first, you see the little number 1. It's a natural hand interaction in VR, and we are going to see that in more detail later. Number 2, we can really help in improving the head tracking, the head position tracking, without the need of an external sensor, by mounting our camera on the headset and tracking feature points in the scene. We can really improve that kind of tracking. Number 3 is object reconstruction and recognition. So because the camera sees in 3D, everything that's in front of the camera can be analyzed. So we can detect a desk, we can detect specific objects, persons, and extract some interesting features like, okay, if there is a desk, then you can transform it, you as a game designer, into a virtual user interface that you can interact with. Then we can also apply our technology for integrating the full body of another person into the VR experience. So that hasn't been done yet, and we're working on that, and that's a really great experience. So more specifically about natural hand interaction using our system. So it's really 2 components. One component is the sensor mounted in the HMD, as you can see on the left side of the screen, and that camera, that sensor is actually looking at what's in front of it. And the second part is the hand tracking software. And what that software is doing is first recognize what are the hands versus the other object in the scene, isolate the hands, then reconstruct the shape of your hand in 3D inside the game or the application. And so it's a real 3D mesh, but it's exactly your hand shape. It's not an artificial hand. And that makes a difference in terms of a connection and feeling of immersion. The software is also tracking some key points on the hands, so fingertips, palm orientation, joints, etc., etc. It's also recognizing a bunch of gestures, specific gestures, like a grab, like 1, 2, 3, 4, 5, and also a bunch of specific gestures, like a circle or swipes, or anything that can be handy for interaction. So this is really what we call natural interaction in VR. So what can you do with that technology inside your game and your application? So first, you can have physical interactions with objects. So it's really about just pushing objects, knocking objects, scooping objects, really exactly as you would do it in real life. And again, that brings a sense and a feeling of presence and a connection with your body, which is really interesting. And just by seeing your own hands versus a pre-animated hand that you could have from a handle device, it gives you a sense of scale and a real connection with your body, and that really reduces uncomfort that you could have when you don't see any parts of your body actually in the game. So you can also do more specific tasks like drawing in the air, or touching buttons, using a UI, etc., etc. So, okay. Now the really interesting part is when you start to use that technology in a multi-user environment. So it's not only you, it's also having other users and players inside the same environment as yours, using also their own hands. And so you're actually capable of seeing those hands and seeing what that other user is doing. And again, that really helps in understanding the intention of the other user. You know, communication, it's not only about talking, it's also a lot about non-verbal communication, and myself, I'm using a lot of my hands when I'm talking, and that helps to understand, hopefully, what I'm trying to explain. And that's the same in VR. Well, you know, in games, having limited freedom for hands movement can work, because a game designer can design around those limitations and makes the experience really good. But in a more professional application, when I say professional, I mean more B2B type of applications, where it's more about sandbox experience. Those limitations with handheld device are really annoying and limiting the efficiency of the experience. So in those type of professional application, having your own hands in the full freedom is really an added value. And I want to show you a couple of professional B2B type of application using that technology. So natural interaction in multi-user environment. First one is a use case about designing complex objects. In that case, this is about proteins and new atoms and new molecules, where drug designers really enjoy using VR, because for the first time they can really see their structure in 3D and they really understand the real structure, but they are still lacking a way to naturally interact with that structure. And again, when it comes to design, it's a lot about communication. And again, verbal communication is not enough. And really being able simply to be able to point at things that you are talking about and really precisely showing what you are talking about and what you are explaining really helps in it really improves the efficiency of the experience. Yeah. Another very important aspect of that technology versus other hand interaction is that the learning curve is really easy. I mean, it's basically just using your hands as you do in your real life. So you don't have to learn any type of button combination or triggers that you can find on a regular handheld device or gamepads. And again, in professional application, B2B application, that's important, because those persons, they don't want to spend time just learning the system. They just want to be able to use it immediately. So another interesting use case for natural hand interaction and multi-user environment is everything related to training, learning, and support. So practicing complex tasks such as manipulating user interface, or learning to drive a car or a truck, or assembling complex parts together that are executed with your own hands in real life is significantly improved when you do that and you train yourself by using also your real hands in the VR environment. And in addition, the multi-user technology enables a remote person to help you in doing the task that you need to learn and accomplish. So let's say I need to assemble some objects or repair something with my hands, and I cannot do it. I can have a remote assistant just doing exactly the same movement, and I can see that in my VR environment, see his hands doing exactly the movement and the action that I would need to do to accomplish the task. And so that's something you cannot really do with another technology, with a handheld device, for instance. That's really too limiting. So next step for natural interaction will be to add not only the hands but the entire body. And so that's something that we are working on. I guess you've all experienced those games and applications and demonstrations where you are supposed to have a body but you don't. Or when you have one, you are looking at it but it's not moving. And in both cases, it gives an uncomfortable feeling. So adding the really full body reconstruction and tracking will really improve that feeling of presence and immersion. And actually, there are already a lot of companies working on that kind of full body reconstruction and multi-user experience in VR. such as that startup in Paris, Mimesis, was really working on the what they call the virtual presence using depth sensors and 3D cameras. So hopefully the last video is going to work. No, it's not, so that's a shame, because that would have shown you, maybe if you get out of the full screen and go back in, we will, because the first video was working, right? I think it's important to show you the video here. No. Or if I give you the USB stick and just play it from there, yeah. Just to show you how it looks like for real. I don't have a demo here, but I'm supposed to have a video for you. So what I wanted to say during the video is that, of course, our technology also has a lot of challenges. Like using your hands in the air, you don't have haptic feedback, which is kind of a big problem. No, sorry, it's the HMD, yeah. So you'll have the long version. Here we go. Yeah. So you don't have haptic feedback with by using that technology, which is a real limitation. You don't have buttons in your hands, which is also a big limitation, especially for gamers. Buttons are the most precise and the best feedback you can have for an action. You don't have that with using your hands in the air. It's also difficult to cover a very wide field of view. While when you have an external sensor looking at light bulbs and stuff, it's easier to track that in large movements. But all those limitations are going to be addressed in the near future, and the solution probably resides in using a combination of different sensors. It's not going to be only about handle device or only about depth sensors. It's probably going to be a combination of that plus something else. That's it. So I'm happy to answer questions. If there is a microphone around. Here, someone. Yeah. We're missing the. You want mine? There. Okay, here we go. Sorry. Thanks.
Yeah, sorry to have. You are mentioning the field of view currently. How wide is it?
Sorry, can you repeat it?
The field of view.
Field of view, yes.
Yeah, currently with this version, what sort of coverage do you have?
Yeah. So far we have a 90 degrees horizontal field of view.
To which distance?
Excuse me?
Distance.
And distance it's today about arm length. Yep. That's what you need to track for the moment. Yeah. And the ideal field of view, I mean, the minimum field of view that we would like to reach would be more like 110. Really, to at least cover the field of view, of course, of the HMD, and ideally even a bit larger than that, so you can already start tracking what you are doing, even if you don't see that happening. That can be handy. Let's say, if you're holding a sword or whatever object behind you, and you want to be able to know what's happening there, even though you are not seeing it.
Thanks.
Yeah. Thanks for now. All right.
Okay. Thank you very much, Eric.
Yeah, pleasure.
Please thank Eric for his excellent presentation.